Hello friends, today we are going to study about pH and pKa. So first, what are acids? Acids are the substances that donate proton or hydrogen ion. In water, they produce hydrogen or hydronium ion. They can accept a pair of electron, they are sour in taste and the pH is less than 7. Now this is a simple representation of an acid. Here Ha is the representation of an acid because Ha can dissociate into H plus, which is a proton, and A minus, or we can say Ha can donate proton. Therefore, Ha is an acid because it can donate proton or it can dissociate into H plus plus A minus. Now this A minus, it can now accept a proton. So what are base? Base are the substance that accepts proton. Acids are the substance that donate proton. Base are the substance that accepts proton. So here A minus is the base which is formed from this acid after it donated its proton. So this base is known as conjugate base. This is a conjugate base of this particular acid. Acid is a substance that donate proton, and after donating proton, the leftover part can act as a base because it can now accept a proton. So this combination is known as acid and conjugate base combination. This base is formed from this acid after it donated its proton. Clear? Now let's look to one of its example. For example, here the acid is acetic acid, CH3COOH. It can dissociate into or it can donate H plus, a proton, and after donating proton, what is left over? CH3COO minus, which is a base, acetate base. Okay, so acetic acid and its conjugate base, that is acetate base. After donating proton, this acetic acid convert into acetate base. Let's look to another example, that is sulfuric acid, H2SO4. It can donate 2 protons. So H2SO4 can dissociate into or it can donate 2 protons plus a sulfate base, SO4 2 minus. Clear? So acids are the substances that donate protons, and after donating proton, the leftover part can act as a base because it can now accept a proton, which is a property of a base. So the property or character of an acid is any substance that can donate proton. On its contrary, bases are the substances that can accept a proton. Clear? Next, acid can be divided into a strong acid and a weak acid. Strong acid means the acid that can dissociate completely into H plus plus A minus. Weak acid means the acids that dissociate partially into H plus plus A minus. Any acid that can dissociate completely into H plus and its conjugate base, that acid is known as strong acid. If the acid dissociates partially into H plus plus A minus, the acid is known as weak acid. What is pH? It is the power of H plus, or we can say it is inversely proportional to H plus. It also tells us that how much amount of H plus is present in a solution. So we write pH as it is what it is written, inversely proportional to H plus. Right? If you remove the proportional sign, then it will become pH is equals to log of 1 upon H plus. So that means the relation between pH and H plus is an inverse relation, inverse proportionality, related as logarithmic. That means if we increase the H plus, the pH will decrease because it is inversely proportional. But how it will decrease? It will decrease logarithmically. That means if we increase the concentration of H plus 10 times, the pH unit will decrease by 1 unit because log 10 value is 1. If we increase the concentration of H plus by 100 times, there will be change in the unit of pH by 2 unit because log 100 is 2. Similarly, if we increase the concentration of H plus by 1000 times, in pH there will be change in unit with by 3 unit because log 1000 is 3. Understood? So that means because they are inversely proportional, increase in concentration of H plus will decrease the pH, or decrease in concentration of H plus will increase the pH. But how much increase or decrease will happen? It is logarithmically. Logarithmically means if there is a change in concentration of H plus by 10 times, there will be change in pH unit by 1. If there is change in H plus concentration by 100 times, there will be change in unit by of pH by 2. If there is change in concentration of H plus by 1000 times, there will be change in pH unit by 3. Understood? Now see this formula here, the same thing written, pH is proportional to 1 upon H plus, that is equals to log 1 upon H plus. If we solve the equation, then we can get log 1 minus log H plus. So log 1 is 0 minus log H plus. So it became minus log H plus. Understood? Next is ionic product of water at room temperature. Water can dissociate into H plus and OH minus at room temperature. The concentration of water is 5.5 molar. When it dissociates, it gives 10 to the minus 7 molar of H plus and 10 to the minus 7 molar of OH minus. That means water do not dissociate completely into H plus and OH minus. So dissociation constant can given by the formula Kw is equals to concentration of H plus multiplied by concentration of OH minus. What is the concentration of H plus? 10 to the minus 7. Concentration of OH minus 10 to the minus 7. So the answer is 10 to the power minus 14. As pH is H plus dependent, so the formula is pH is equals to minus log 10 to the power minus 7. 10 to the minus 7 because H plus concentration of H plus is 10 to the minus 7. So log 10 to the power minus 7 is minus 7. So here one minus sign is there. So minus in the bracket minus 7. The answer is 7. Understood? The pH of pure water varies with temperature. Why? Because as we increase the temperature, the water dissociation also increase. Now here we saw that at room temperature, say 28 degrees centigrade, they dissociates into H plus and OH minus with concentration 10 to the power minus 7. So 10 to the power minus 7 H plus also is present, plus 10 to the power minus 7 OH minus is also present. Correct? H plus is responsible for pH. More H plus, pH will go down. OH minus is responsible for POH. More of OH minus, POH will go down. Correct? So that means if we increase the temperature, we'll get more of H plus and more of OH minus. At 28 degrees centigrade, we got 10 to the minus 7 of H plus and OH minus. Now say for example, if we increase the temperature by 29 degrees centigrade. This is just for example I'm taking. Okay. So suppose it became 10 to the power minus 6. So this is H plus, this is OH minus. So H plus also increased, OH minus also increased, but they increased at the same rate. So water will always be neutral. Correct. If we change the temperature, because we are saying the water will dissociate more, we will get more H plus, we will get more OH minus. Water will still remain neutral because the increase in concentration of H plus and OH minus is at same rate. So water will always be neutral, but the sum of H plus plus OH minus will differ. So what we are saying, as we increase the temperature, the dissociation will increase. That means we'll get more of H plus and more of OH minus. So when we add the concentration of these H plus and OH minus, or we can say when we sum total pH and pOH, they won't be equal at all the temperature, but water will be neutral at all the temperature because this pH and this pOH change happen at the same rate. They both will reduce at the same rate. Correct? If we increase H, the pH will reduce. If we increase OH, the pOH will reduce. So because H plus and OH minus is increasing at the same rate, hence pH and pOH will also go down at the same rate. So because the rate is same, the water will be neutral at all the temperature. But if we add their pH and pOH, it won't be same in all the temperature. Understood? Clear? So what we are saying is water dissociates into H plus and OH minus. At room temperature, this dissociation is 10 to the power minus 7 and 10 to the power minus 7. Clear? If we increase the temperature, the dissociation will be more. H plus is related with pH. How? pH is proportional to 1 upon H plus. OH minus is related to POH. How? The same. Here the POH will be proportional to 1 upon OH minus. So the relation is same. The way pH is related to H plus, in the same way POH is related to OH minus. Clear? So in both the situation, because they are inversely related, so increase in H plus concentration will decrease the pH, increase in OH concentration will decrease the POH. Because they will decrease at a same rate, therefore water will be neutral at all the temperature. But because dissociation is more, therefore if we add pH and POH, this won't come same at all the temperature. Next, how we will calculate pH of a strong acid. Now, strong acid can be of two types. One is monoprotonic, another one is multiprotonic. What do you mean by monoprotonic? Monoprotonic means mono means single, protonic means H plus. If they are donating single H plus, that acid is known as strong acid. If they are donating multiple H plus, the acid is known as multiprotonic strong acid. Now how we will calculate the pH of monoprotonic strong acid? The example of monoprotonic strong acid is HCl, HF and HI. It is strong acid. That means there will be complete dissociation. So complete dissociation means the concentration of strong acid is equal to the concentration of H plus, or we can say the concentration of H plus is equal to the concentration of strong acid. Clear? Now if anybody asks you to calculate the pH of 0.01 molar HCl, so how we will find? The concentration of HCl is given 0.01 molar. HCl is a strong acid, so it will dissociate completely into H plus and Cl minus. So if the concentration of HCl is 0.01 molar, the H plus will also be 0.01 molar, the Cl minus will also be 0.01 molar because complete dissociation. Now pH is minus log H plus. So minus log, the concentration of H plus is 0.01. That means 10 to the power minus 2. Log 10 to the power minus 2 is minus 2. So this minus sign in the bracket, log 10 to the power minus 2, that is minus 2, minus minus plus, so plus 2. Got it? Now in the same way, if we need to calculate the pH of 0.01 molar H2SO4, multiple H plus, so it is multiprotonic. How we will calculate now? The concentration of H2SO4 is 0.01 molar. It gives 2H plus. So 0.01 molar for 1H plus, 0.01 molar for second H plus. So total is 0.02 molar H plus 0.01 molar SO4 minus. Now the same, pH equals to minus log H plus. So minus log, here it is 0.02. That means 2 into 10 to the power minus 2. So now log 2, here because multiplication, so in log we do addition. So log 2 plus log 10 to the power minus 2. The value of log 2 is 0.3. Log 10 to the power minus 2 is minus 2. So by solving it, we'll get 1.7. Clear how to solve the pH of monoprotonic or multiprotonic strong acid. Now how we will calculate the pH of strong base? The same. Just instead of pH, we have to find POH. Okay. Let's see. Here example is KOH. Strong base, that means concentration of OH minus is equals to the concentration of strong base. So the same concentration 0.01 molar KOH now we have to find. So because it dissociates completely, so 0.01 molar of K plus and 0.01 molar of OH. So POH is minus log OH. Minus log 10 to the power minus 2. So 2. But it is POH. The question asked is calculate pH. So from POH, how we will calculate pH? pH is equals to 14 minus POH. That is 14 minus 2 is equals to 12. So the pH of the solution will be 12. Clear for all? So how we will come to know what is the pH if the strong acid is diluted a lot. So one thing is, it is acid. That means definitely the pH won't be 7 because 7 is for neutral. It won't be more than 7, 8, 9, 10 because this is the base side. So definitely as pH should be less than 7 only. But because it is diluted a lot, that means the pH will be slightly less than 7. Maybe 6, 6.7, 6.8, like this. Correct? So pH of a very dilute solution of strong acid, how we will find? Because it is acid, definitely pH won't be 7, pH won't be more than 7. So pH should be less than 7, but as because it is diluted a lot, so pH will be slightly less than 7. Correct? So pH will be slightly less than 7. But when we dilute any strong acid, in that case, the water H plus also become active. So now, in this case, if the solution is diluted, the total H plus is the H plus donated from this acid also and the H plus donated by water molecule also. Now pH of a very dilute solution of strong base. The same theory applies here also when we are talking about base. So definitely it won't be 7 and it won't be less than 7. So it has to be more than 7. But as because it is diluted a lot, so it will be slightly more than 7. So in many competitive exams, you generally get questions from pH for which many times you did not have to solve the questions also. They'll ask you any question like if there is a concentration of 10 to the power minus 10 of HCl. So it is HCl, strong base, 10 to the power minus 10 molar concentration. So how much it is diluted? What will be the pH? And they will give you 4-5 options. They will generally give you the options like 6.9, 7, 7.01, 7.2, like this they'll give. So you have to choose, you have to calculate the pH. What they have given you, 10 to the power suppose minus 12 molar HCl. So 10 to the power minus 12 molar HCl means how much it is diluted. So it is a very dilute solution. They will ask you to calculate the pH and they'll give you options like this. No need to solve. By seeing the options only, you can say what can be the pH of that solution. Clear? Now, how to find out the pH of mixture of two acids or two base or an acid and a base? In this, two conditions are present. First condition is if they are present in equal volume. So if two acids are mixed in equal volume, the pH will be lower than their average pH and closer to strong acid. Suppose two strong acids are mixed. One pH is 2, another pH is 4. You have asked to find out this is acid A, this is acid B. These two acids are mixed. You are asked to find out the resultant pH of this solution when A plus B are mixed. So the average is 3, but you won't get the result as an average of their pH. It will be less than average and closer to strong acid. So maybe you can get 2.5, for example. Clear? The same theory applies for base also. If A and B, two bases are mixed, if their pH is 8 and 10, what will be the pH of the solution having the combination of A and B? So if they both are mixed in equal volume, the average will be 9, but it won't come 9, it will be closer to the strong base. Slightly more than the average, closer towards strong base. For acid, slightly lower than the average, closer towards the strong acid. If an acid and base both are mixed in equal concentration, the pH will be around 7 only. If two acids are mixed, the pH will be lower than average, closer to strong acid. If two base are mixed, the pH will be more than average, closer to strong base. If an acid and a base are mixed, the pH will be around 7. Next, if they are mixed in different concentration, then we have to apply formula. For two strong acid, the formula is H plus is equals to N1V1 plus N2V2 divided by V1 plus V2, where N1 and N2 are the strength of acid 1 and acid 2, V1 and V2 are the volume of acid 1 and acid 2. Similarly, for two bases, the formula is again the same. OH minus equals to N1V1 plus N2V2 upon V1 plus V2. If one strong acid and one strong base are mixed, in that case, suppose N1V1 is the strength and volume of acid, N2V2 is the strength and volume of base. So if N1V1 is more, that means acid is stronger. So the resultant solution will be acidic. If N2V2 is more, that means base is more. So the resultant solution will be basic in nature. Now pH of weak acid. How to calculate the pH of weak acid? Weak acid means the acids that do not dissociate completely into their ionic forms. For example, citric acid, acetic acid, etc. Mostly in a biological system, we'll find weak acid like citric acid, acetic acid, malic acid, fumaric acid. So in the biological system, we find only the weak acids. Okay. So in case of weak acid, as because they do not dissociate completely. So the formula is Ha plus H2O. It gives H3O plus A minus. So dissociation constant will become the concentration of H3O plus multiplied by concentration of A minus divided by concentration of Ha. So if you are given a group of 3 to 4 weak acids, and if you are asked to find out among these weak acids which is the stronger, so you will go with Ka. You have to see the Ka value. The acid having more Ka value is the stronger acid. Clear? Now, 0.01 molar concentration is given of acetic acid, which dissociates only 10%. How you will find the pH? So first you have to find what is 10% of 0.01 molar. Correct? So 10% of 0.01 molar is 0.001. That is 10 to the power minus 3. Now apply the formula of pH. pH equals to minus log H plus. So here H plus concentration is 10 to the power minus 3. Because acetic acid do not dissociate completely. It is a weak acid. So if the concentration of acetic acid, that is if we say HA, acetic acid, this is acetic acid. Its concentration is 0.01 molar. It dissociates into H plus and A minus, but not dissociates completely. So this concentration won't be 0.01 molar. It is dissociating only 10%. So the 10% of 0.01 molar will be H plus and the same value will be A minus. That means 10% of 0.01 molar is 0.001. So HA in this case, which is acetic acid, will dissociate into H plus and A minus with concentration 0.001 molar of H plus, 0.001 molar of A minus. Clear? Now suppose if you have given Ka value and then you have to calculate pH. So what you have, the formula is Ka equals to H3O plus into A minus upon Ha. Acetic acid, that means Ha, 10 to the power minus 2. So here 10 to the power minus 2. Ka 10 to the power minus 5 already given. So 10 to the power minus 5 into 10 to the power minus 2 is equals to H3O plus and A minus. Now here dissociation is not complete. So we cannot say what will be the concentration. But at least whatever be the concentration is, it will be same. If H plus is 0.001, A minus will also be 0.001. So these two concentrations are same. So we can write 2x. So if 2x, that means how we will calculate x? It will be root over 10 to the minus 5 into 10 to the minus 2. Clear? So the value of root over is 3.16. Understood? What is pKa? pKa is that pH of weak acid when the acid is half dissociated. So pKa is the pH where weak acid is half dissociated. It means the concentration of Ha and A minus is half, 50%. This combination can act as a buffer because it can resist the change in H plus and OH minus. So the pKa is equal to minus log Ka, or we can say pK is proportional to 1 upon Ka. Correct? So pKa is inversely proportional to log Ka. For example, acetic acid, it half dissociates at pH 4.76. That means this is pKa value of acetic acid. Understood? acetic acid, half dissociate at pH 4.76. So this pH is pKa for acetic acid. Clear? Now why this combination can act as a buffer, we can understand this better in the next video when we'll study about buffer. Till now, all these for pH. I hope you understood the fundamentals of pH. So now one question from my end to you all. You have to calculate the pH of 10 to the power minus 8 molar HCl and let me know what is the pH of this solution. Clear? So you have to calculate and let me know the answer, that what will be the pH of 10 to the power minus 8 molar HCl. Do let me write in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.